All right, we are live. Good morning, everyone. I am Vino Duraisamy. I work as a developer advocate at Snowflake. And in today's episode, we have a lot of exciting topics to cover, starting with pandas, Modin, pandas on Snowflake, and so much more. Well, pandas is a powerful and a very popular open source library for data manipulation and analysis. We are all data practitioners here. I don't have to explain what pandas is to all of you, but nonetheless, you know that when we have high memory usage and also due to the nature of lack of distributed computing capabilities, it is a bit challenging to work with pandas on large data sets. Well, that's where we had this new and fresh, modern and open source project that accelerates our pandas code to run in a distributed manner. Well, now thanks to the power of Modin, pandas on Snowflake lets you run your pandas code with absolutely minimal changes and run all of it in a distributed manner directly on your data in Snowflake. Wow, that's a lot of terms that we learned with pandas, Modin, and pandas on Snowflake. Well, to dive deep into all of these and show you a cool demo on how you can get started, I have with me today Doris Lee, who is the product manager at Snowflake. She is also the co founder of the company behind Modin. Well, welcome, Doris, to the show. We are super excited to hear from you and learn all about pandas, data frames, distributed data frames, and so much more.
Thanks, Vino. Super excited to be, in this live stream today, to be talking about all the cool work that we're doing with Pandas on Snowflake and our open source project Modin. Before we get started, I just wanted to give a brief overview of the work that we've been doing here, set some context. So I'm gonna go ahead and share the slides here and provide kind of an overview of what we've been doing here. So as Vino said, Pandas is this like tremendously popular open source library. It's probably one of the most popular libraries for working with your data in Python. It's used for anything from data cleaning, transformations, data analysis. And the reason why people love it so much is because it's so flexible. It has a broad range of APIs, anywhere from like statistical analysis to cleaning up your data to doing merges and joins, and so on. And it also lets you work with your data in a very intuitive manner. So you have this pandas data frame, this data structure that you can work with, and it's really great for these types of like interactive analysis, and quick prototyping to build out your Python pipelines, so that you could start working and looking at your data and then start working with it. And this is a reason why Pandas is such a popular library. It's been around in the community for a long time, and it's widely popular. And so, obviously, as in my role as a product manager, like I spend a lot of time talking to our customers, especially our customers who are interested in using Python. And one of the things I hear a lot is like, "Hey, like I want to use Pandas. Pandas is great, right? Like I want to use Pandas with my Snowflake data. Like, what do I do here?" And one of the most common approaches that we see here is kind of pulling your data out of Snowflake using one of our Python connectors. So maybe like, session.table using Snowpark and then doing a two pandas on it, or using the Python connector directly to pull that data into memory into your machines. Now, this is not an ideal approach because whenever you're doing this type of like two pandas or using the Python connector, what happens is that the data gets pulled in serially. You kind of lose all of the rich performance and governance benefits that you get with Snowflake, which can lead to sort of out of memory issues. If you're using a notebook kernel, it can lead to out of memory issues and the notebook kernel crashing, or single threaded processing, which can be really slow if you're working with large amounts of data. And so obviously at Snowflake, we want to make sure that everything that you're doing here is sort of easy, connected, and trusted. And that's true also for whatever your experience is with pandas on Snowflake. And so this is why we decided to build Pandas on Snowflake really as this simple and unified interface for working with your Snowflake data using your familiar Pandas API. And so some of the key benefits, I'll show a demo of this a little bit later, but some of the things I wanted to call out here is like the fact that, hey, you can connected to your data. You can, easily read in your tables and, views, and so on, bring in files from elsewhere, and start working with it in Snowflake. You can build robust pandas pipelines at all scales, and then also very flexibly being able to work with your data, leveraging Snowflake's powerful analytics function. And so that's kind of like at a very high level some of the key capabilities that we offer with pandas on Snowflake. Now, one of the exciting things that Vino mentioned earlier was that, the Pandas on Snowflake offering is built on top of this Modin open source project. So the Modin is an open source project that is essentially kind of like a scalable drop-in replacement for Pandas that is built on top of distributed compute frameworks such as Ray and Dask. And so we've been building Modin over the last 5 years as an open source project. And the way it works is it's kind of like a drop-in replacement for Panda. So all you have to do is change a couple lines of import. So instead of doing like import pandas as PD, you do import modin.pandas as PD. And all your code stays the same. You can continue to do things like read CSV, group by, and so on. But underneath the hood, we are leveraging distributed compute to run your pandas operations in parallel, so that you can operate on much greater scale of data and working in parallel. And so this is an actively maintained open source project. Modin is an actively maintained open source project that we're working on as part of Snowflake, and really leveraging some of the research and techniques that is based off of database and distributed computing techniques, and kind of applying that to pandas and the data frame realm. And so this is something that our Pandas on Snowflake offering is also built on top of this open source project. And so a little bit more on how Pandas on Snowflake works. Pandas on Snowflake, really solves that issue that we talked about earlier, which is like, hey, I'm pulling my data out of Snowflake, right? And, I'm losing all of this like performance benefits and so on. Instead, what Pandas on Snowflake does is that it brings your code closer to your data and says, hey, I'm going to take your pandas code. Let's say you write something like pd.concat. I'm joining, combining two data frames together. I'm translating that into a SQL query that is then run on your Snowflake data, so that your data never has to leave Snowflake. The query is directly translated to SQL and then pushed down to run on the Snowflake engine. And so there's all this benefit that comes with doing that. And I don't want to bore you with the numbers, but these numbers are like really, really impressive. And so like the gray bar here is showing, what you would like the performance you would expect if you were running regular pandas on like, your local machine or something. And then the blue bar is where the performance of pandas on Snowflake. Now, the couple things I want to call out here is that on like the two gray bar on the right hand side, beyond like a certain scale, pandas doesn't even run. It just kind of crashes. The job doesn't even finish because you run into these like out of memory issues. And then on the smaller scale, even on like the 1 gigabyte or like the 10 gigabyte range, we're getting like up to 30x faster performance than compared to pandas. And so this is really the performance benefit that you can achieve by using pandas on Snowflake with very minimal changes to your code that is needed to start using this today. And then finally, one of the things I'm really, really excited about, this is an announcement, a private preview announcement that we made at Summit this year. Our team has been extending our Pandas on Snowflake offering to support hybrid execution. And so hybrid execution is this new mode of working with pandas that is a significant step towards supporting pipelines at all scales. With hybrid execution, we intelligently figures out, hey, like if your pandas code is more efficiently run using local in-memory pandas, or if we should push it down to Snowflake Compute. So typically what we see with customers, workloads is that, sometimes you're working with like small-ish data, and it's actually really fast to run that locally in memory with pandas. And so we want to do that and then be, really efficient with your queries. And when you scale up to production, let's say when you're going from prototype to these production large-scale pipelines, then those are the types of use cases where we actually push it down and translate that to SQL. And so we've gotten really good feedback and excitement around this feature. And right now we're in the kind of the private preview stage, and really excited to see all the cool things that people are building with this new capability. And yeah, this is kind of a bunch of QR codes. I will also drop the links on the chat on how you can get started in using pandas on Snowflake. I'm also happy to share a demo, but before we do that, I want to make sure we get to our audience question and any questions that Vino also has. And feel free to drop any of your questions in the chat.
Fantastic. Firstly, thank you so much, Doris, for going over the story of pandas, Modin, and also how pandas on Snowflake work. And like you said, we would all love to see a demo of how that works. And meanwhile, for everybody watching, send in your questions in the comments. And we would also like to know if you worked with pandas before, or are you trying to learn pandas for the first time? Let us know in the comments. All right. Demo time. Who is excited? I think before seeing the demo, I do see some questions, but maybe I will save the questions for the end, Doris. We could.
Okay. Do you want me to show the demo first?
Yeah, well, let's do the demo first and then take the questions in the end. But folks, keep the questions coming in the comment sections. We will get to it.
Awesome. Okay, so let me share my demo. So you could see here that I have my Snowflake notebook open. For those of you that aren't familiar with this interface, this is our Snowflake notebook interface. I've been able to log into Snowsite, which is our Snowflake UI. And then you can see that this looks and feels like your regular notebook. It lets you run through kind of these cells. Our Snowflake notebook offers both like kind of a Python cell as well as a SQL cell. So you can kind of add in these cells, work on markdowns and so on. So we make it super easy for you to like work with your data using Snowflake notebooks. And so that will be what I'll be using to show the demo today. Before I get started, I'm gonna just, I'll just run this. Okay. So in order to use, pandas on Snowflake, I can actually go down to my packages pane, sure that Modin is selected as part of the dropdown. And that's how I add the Modin package into my Snowflake notebook. And then with that, I should be able to run these two import statement, which is needed for getting started with pandas on Snowflake. The other thing that I can do here is I can use these two commands to get an active Snowpark session. Now, the session information is important so that I can connect to Snowflake and then kind of get the session information. And then in this example, I've generated kind of a synthetic data set with just like 3 columns, which is a revenue transactions table. And this table is around 50 million rows. So this is intended to be like a medium-ish, large-ish data set that we'll be working with. And then, as I mentioned, there's kind of these two approaches, right, to working with, your Snowflake data with pandas. One is kind of this naive approach, which requires you to pull all of your data in memory into pandas. And we can kind of take a look at what this looks like. I'm not going to run this code here because, as you can see, this takes some time, right? And the way this works is that I create kind of a table reference to this table, and then I do a kind of a two pandas call. And this two pandas call, what it does is that it pulls all of that data into memory, into pandas. And then I measure the time before and after, and calculate the time. It takes about 50 seconds to run this. Not super slow, but I'll show you how fast it is to do it with pandas on Snowflake. So with pandas on Snowflake, we have this read Snowflake command. This read Snowflake command allows you to kind of read in, your tables, your views, your dynamic tables, and so on. And so with this single line of code, you can immediately sort of be able to make a kind of a Snowpark Pandas data frame out of this. And you can see this takes like, 0.3 seconds. I keep running this. This is really fast. Unlike this query, which is almost like 10x more time. And the reason why this is so fast is when we run this pd.read Snowflake command, it's not actually pulling all of the data in memory. So it's not pulling all those 50 million rows into my notebook's memory. It's kind of just creating a reference to that. It's lazily evaluated. And so this is a really efficient way of hey, I have my DF reference, my DF data frame reference, and start working with it with pandas on Snowflake. I also wanted to note that, hey, like instead of putting in just kind of a table reference in your pd.snowflake, you can also put in, let's say, a SQL query. So sometimes people like to intermix SQL queries with Python and pandas code. And so pd.read Snowflake also can take in kind of a SQL query. And if we run that will run the SQL query and then fetch that as like a Snowpark Pandas data frame that I've then printed here. And so now that I have my data frame DF reference, I can print out the head. I can take a look at head is essentially taking a look at the first 5 rows of the data. I can take a look at the shape of the distribution. So I have 50 million rows and then 3 columns. I can also plot df.describe. Describe is a really easy way for you to get an overview of the summary statistics in your data. I usually like to run a df.describe when I ingest new data or I'm working with a new table. Just want to get an overview of what my tables look like. And so I have, with df.describe, I have one column that is quantitative in this data set. It's the revenue column, and it tells me the min, max, percentiles, and so on. So this is a really useful way. Instead of me having to write 10 different queries to calculate all of these statistics, it's just literally like a single line of code. Now, those of you that are familiar with pandas will probably recognize that, hey, like all of this just looks like pandas code, right? Like it's not really like all that exciting. Everything looks exactly the same as pandas. But again, here we're using our Snowpark Pandas API, which is what which is how we're using pandas on Snowflake, and all of that. All of what we're doing here with pandas is getting translated into SQL code that is running in the backend. And I want to show you that this is actually happening. And so the fact that we just ran all of these queries, I did some additional data transformation to look at data based on the last 7 days of data, based on the max date. I did all of these processing. You can see that I filtered my data from the 50 million row data set now down to around 40,000 rows. And as I mentioned, all of this is running in SQL. And so just to show you that this is actually happening, I'm going to go into my query history view. Let me just make sure that this is okay. I need to share a different screen now. Let me make sure. Let me just share my entire screen. Okay, so I was right here in my notebooks. I went into monitoring, and then I created a new tab called query history. And so this is the query history view, which shows me all of the queries that I've just been able to execute. And as you can see, some of that filtering that I was doing got translated into these SQL queries that corresponds to the pandas queries that I've written. So this actually tells you that all of this pandas code that you saw here, even though it looks and feels exactly like Python and pandas, is actually getting executed on the Snowflake backend. And this is kind of your proof for that. Like these are all the SQL queries that are associated with the stuff that I just ran. And so this is also a good way to sanity check and make sure, hey, like, if I was running this query and it was taking like some time, what is the query that's associated with it? I could always go to my query history and take a look at like the SQL query that has been generated and so on. And so finally, like here I show a very simple example of like, hey, I've been able to do some transformations, build kind of a simple pipeline where I, get the max and then filter the dates based on that. Now that I finished this transformation, I want to save that back into Snowflake. And with Pandas on Snowflake, we offer you kind of a wide range of APIs for saving your data frame results back to Snowflake. So one of the easiest way to do this is, let me just make sure there's if exists. So this table already exists. So you can use the toSnowflake command and save this filtered DF into this new table called filtered revenue transactions. And you can see that the parameter that I just added is if exists, because I ran this code earlier and it already created the first data frame. So I'm going to just do a create or replace and replace that data frame again. So now that I've been able to run that, I want to make sure that this table has actually been created. And so I can do a very simple select star query and show that this table was indeed created, and this was the filtered data frame that we have because it was created by this filter DF. Now, this is also a really cool thing that I want to show because earlier I mentioned in this Snowflake notebook interface, it's a really easy way for you to work with both SQL and Python queries. Here you could see that this is an example of a SQL cell. So you could see up here, this is a SQL cell. I could change it to a Python cell or a Markdown cell. And so this allows you to interleave, SQL query and Python queries and really seamlessly move between the two. Because sometimes, I personally find it easier to do certain things in Python and certain things easier in SQL and so on. The other really cool thing that we've introduced recently is the ability to save your like pandas data frame and specification into a view, a Snowflake view. And so to do that, you could do filter df.toView, and this is the name of the view. And the way that works is that that creates a view definition based on the pandas pipeline that you've specified. So again, if you remember, our pandas pipeline was basically this like simple filter to the last 7 days based on the max. This is kind of the logical specification of the pipeline that is associated with this filter DF. When we do a toView, it doesn't actually execute that query itself. What it does is it creates a table, or it creates a view based on that SQL statement. And so here, if we run like get DDL and look at the view creation code, you can see that this is the SQL query that is associated with that transformation that we talked about. And this is the name of that view. And so down the road, let's say you want to access that view, maybe even using pandas on Snowflake, then this is when we actually run that view creation code and actually look at what's in the view. And so again, you recall that we used pd.read snowflake earlier in the code. We can use pd.read snowflake here to also read in the view and so on. And so you could see that pd.read snowflake is a very versatile but very unified way of, bringing in your data, whether that's you're working with a table, a view, a dynamic table, even an iceberg table. You're able to kind of use pd.read snowflake to kind of take that data in and start working with a snowpark pandas data frame df and start writing some pandas code. Um, and um, and yeah, that's mostly what I wanted to show. Just to kind of throw in a kind of an extra bonus. Personally, I find it really easy to bring in your kind of data from like S3 or like other places, or even like local files that you have around, like CSV files or Excel files or Parquet files, using pandas on Snowflake. And the way that I can do that is, let's say I have this like S3 bucket. This is our S3 bucket for a lot of our Snowflake quick starts. I can very easily create an external stage linked to this S3 bucket. And then I can use pd.read CSV, which is exactly the same syntax as, pandas, pd.read CSV. We support a wide variety of IO functionalities that is listed on our documentation page. Everything from read Excel, read JSON, read Parquet, and so on. That allows you to really easily bring your data into Snowflake as a Snowpark Pandas data frame. And so you could see that when I run the menu df here and using the Pandas syntax pd.read CSV, I can very easily sort of get this menu df and then start working with that. So this is a really quick and easy, just like a one-liner to bring in your data from a CSV file or like an Excel file into Snowflake and start working with it with pandas. So yeah, I'm happy to kind of, how do I stop sharing? Okay. Happy to answer any questions in the comments here.
Okay, cute. Standard. I was going to say, we have a bunch of questions from the audience here. One of them primarily being, from a developer's point of view, when I use Snowpark data frames on Snowflake versus like pandas data frames on Snowflake, how is it different? Because I know even for Snowpark, the queries are internally, like the data frame APIs are internally getting converted into SQL queries and run. And I'm assuming it's the same with pandas as well. So what should I know in terms of performance from the developer's point of view?
Yeah, that's a really great question. And so our Pandas on Snowflake offering is delivered as part of our Snowpark Pandas API, and it's actually part of the same library that the Snowpark Python data frames is distributed in. So when you go to our like GitHub or like our PyPy and do like a pip install, Snowflake dash Snowpark dash Python or something, you actually get both. You get both the Snowpark data frame and you get the Snowpark Pandas API. And our general recommendation here is like, you should use whatever library that you're most familiar with. So the Snowpark data frame API was developed based off of more of like a PySpark API. So if you're coming from more of a PySpark world, you're familiar with that syntax, that might be a little bit more natural to you. If you're coming, from like Pandas world or like used to using kind of the Pythonic kind of syntax, then we would typically recommend using like Snowpark Pandas as kind of the approach. As I showed in the demo here, it's a really easy way for you to, start working with your data. But in terms of like the backend performance perspective, like because Snowpark Pandas sort of essentially uses the same mechanism to push down the compute to SQL and does the SQL translation using essentially the same layer that Snowpark Python data frames does. The performance here that you would expect in the generated SQL is very similar. Obviously, with pandas, there are some additional semantics and things that we maintain that adds a little bit more kind of richness in terms of semantics and API capabilities. But underneath the hood, the performance should be comparable and around the same level.
Gotcha. Okay, I think that's very helpful. And also maybe to sum it up, like from a developer's point of view, the developer experience is very different. For example, if I've already worked with pandas and I want to like think about building a data pipeline in Snowflake, I might as well go with pandas on Snowflake because I'm familiar with the head and the describe and the group by and the joins and everything, and I know how to work with pandas very fluently. Whereas, say, if I come from the Spark world, I would probably try with Snowpark because that's more familiar with what I've been working on. In terms of performance, because both of them use the Snowflake's optimized compute engine under the hood, it's going to be comparable. So it's all for the developer experience.
Mhm.
But if you're vibe coding and if you're letting somebody else write the code for you, so I don't think it makes much of a difference. So you could pick either or. So that said, I think there was another question about also the size of the warehouses we were using for the notebooks.
Yeah, that's not even something that I explicitly said. I think generally like our Snowpark Pandas has been really efficient. As you can see here, I'm using an extra small warehouse. So the queries that we generate is very efficient. Here I'm just using an extra small warehouse that's associated with these queries. And this is around like 50 million rows, if I remember correctly. So you could see that this is you could use a larger warehouse if you're processing more data. But it's, Snowpark Pandas isn't really tied to the warehouse size itself.
Mm-hmm. Also, while you have the screen up, okay.
No, I can share again.
Okay. I was going to say, while you have the screen up there, I also wanted to highlight to the audience watching here that if you look at the import statement, that's probably like the only place where you notice that it is Modin pandas, but everywhere else, it's literally the familiar pandas APIs that you know and love. And it runs distributed under the hood, highly performant, can work for huge data sets at scale, right? Like there's not any difference at all from,
Exactly. Yeah, as Vino said, the code changes here is really minimal. It's really the key change here is, these two lines of import and then adding your connection string, which you would have to do with Snowpark in any case. And then essentially the way you're reading the data, instead of doing a two pandas, you would do a pd.read snowflake to your table. And so below that, everything else, df.head, you're doing shape, describe, and so on. It's all very, pandas-esque. And if you're familiar with pandas, this is probably very familiar to you.
Mm-hmm. Can you also show how did you install packages just one more time for
Yeah,
folks?
so the packages, you can access the packages here in the packages. Let me go up. I basically typed in Modin. I selected it. Oops, that deselected it. Okay, so yeah, I selected Modin. And then for now, you would have to pick the version 0.32. In a couple of weeks, this should be upgraded to the latest. But for now, you would have to pin this at 0.32. I would save that and then start kind of operating on your notebook. And so our notebook offers a really easy way for you to install like packages from Anaconda as well as your own stage packages. And here I'm showing notebooks running on warehouses.
Awesome. Okay. I think, yeah, we are good with the demo. And we probably will take this one last question before we wrap up, which is once you get the data in a data frame and do these transformations, do those intermediate data frames create temp tables in the background? I know you talked about lazy evaluation a bit, but maybe you could, expand on that.
Yeah, that's a great point. And so, yeah, typically the way that we create these Snowpark Pandas data frame queries is that we evaluate only at the point where there's like either a print statement or like a df.head, as you saw in the demo, or towards the end of your pipeline when you have like a to Snowflake. So there are certain operations that essentially like materializes or triggers execution so that it's not lazy anymore. And then so everything before that is kind of like stacked up into a query, and then we essentially evaluate all of that at once. And so that's kind of how things work kind of in the back end. And then any sort of intermediate, obviously we have intelligent optimizations related to our Snowpark library that tries to make that generated SQL more efficient.
Mm-hmm. Awesome. I guess with that said, we are out of questions, and a lot of us here are asking how do they get started and links to the notebooks that you've shared and all of that. So here we go, everybody. Here is the quick start and also a demo video if you want to get started and run it all by yourself. And thank you so much, Doris, for walking us through what pandas is, what is distributed pandas, and how Modin helps pandas scale at Snowflake on Snowflake. Thank you so much.